Coronavirus, including SARS-CoV-2. Coronavirus is shrouded in a single-stranded RNA virus and positive input belonging to the Coronaviridae 99 family. They can infect various species of mammals and poultry, causing respiratory and/or intestinal diseases. Human coronavirus is the main cause of ordinary colds and is responsible for up to 30% of mild respiratory tract infections and atypical pneumonia in humans 100. 4 different coronaviruses are usually circulating in the human population: HCOV OC43, HCOV HKU1, HCOV NL63, and HCOV 229E101. In the last 2 decades, 3 coronaviruses with the potential to cause life-threatening diseases in humans have emerged. Severe acute respiratory syndrome coronavirus appeared in 2002 in China and spread, produced 8,100 infections, and nearly 800 seconds in 37 countries, 100 and 2,103. 10 years later, the coronavirus Middle East respiratory syndrome appeared on the Arabian Peninsula and spread to 21 countries, causing an outbreak in humans and infects around 2,500 people, with a mortality rate of 35%. 105. In 2019, infection by coronavirus, which is now known as SARS-CoV-2, which can cause fever, severe respiratory disease, pneumonia, diarrhea, dyspnea, and the failure of double organs identified in China 106.107. In February 2022, more than 414 million cases were confirmed, which led to at least 5.8 million seconds, according to the World Health Organization 108. All coronavirus enters the host cell using a transmembrane spike trimeric glycoprotein 109. S protein is a class I fusion protein type I and is regulated into 2 functional subunits, which remains covalent in the pre-fusion protein conformation. The amino terminal S1 subunit is responsible for binding to the receptor of the host cell, while the S2 subunit terminal carboxy is responsible for the virus and cellular membrane fusion 111. Subunit S1 is then divided into N-terminal domains and RBD. Fig. 3. SARS-CoV-2 spike protein and antidote antibodies targeting receptor domains. The instructor's representation of the surge protein from severe acute respiratory syndrome coronavirus 2 with a modeled carboxy terminal. Protein domain architecture spike BSARS-CoV-2. The domain structure of the receptor binding is bound to the angiotensin II GDP 6M0J converting enzyme. Neutralized antibodies can prevent the opening of S protein to block the RBD erection, block the RBD to prevent binding to ACE2, blocking amino T.